So you draw it like that. At A, you have 18 kilonewton, and then at 1.2 distance, you have 9 kilonewton. Okay, and then this is 1.2 meter, and then you cut here. So the next 9, which is 1.2 meter, is somewhere there. Alright, something like this. So you cut before the next 9 kilonewton. So what do you have here? When you cut, you have the internal, same, you have the internal shear force V2, and you have the internal bending moment M2. Right? And how about the X? The X here, you can choose. You can take the X to be X2, for instance, X2 to be from A to that point, or you can do from 1.2, so from this point as X2. It doesn't matter, right? So which one you want to choose, it really depends on you, which one you think is easier. But later on, when you express the equations, this range of X2 must be correct. Okay, so we'll see. Okay, let's see we do this X2 from A all the way, right? Okay, so again, the same procedure. To find V2, then we need to do the summation of forces in y direction equal to 0. Summation of forces in y direction equals to 0. So you have 18 minus 9 minus V2 equals to 0, isn't it? And then your V2 here will be again a constant value of 9 kilonewton going down. Alright? So it's constantly, it doesn't change with X. How about M2? So for M2, you the moment about the section area here again, okay? Because you can eliminate V2, V2 won't appear in the equation. So if you do counterclockwise rotation as positive, so you have M2, next M2, plus 9 times X2 minus 1.2. What is happening here? M2 is this direction, counterclockwise rotation. Same goes to 9 kilonewton, because if you do this moment, 9 kilonewton, and then this is the arm, okay? So it causes counterclockwise rotation, same as M2 here. That's why it's plus here, and this is the arm. The arm is this, which is X2 minus 1.2, isn't it? And then the other one is this. So this 18 kilonewton will be minus 18 kilonewton times X2 equals to 0. Why minus X2? Why minus? Because this 18 kilonewton will cause the clockwise rotation, that way around of this M, right? And X2, this is the R. Again, we define this as X2, right? So depends on how you find X2, whether it's this or this. Right? Equals to 0 because it's in equilibrium. So if you rearrange this, then M2 will be 18x2 minus 9x2 will be 9x2. What is this? 9 plus 10.8. Alright, check. Okay, 10.8. Okay, so this is the equation. So this V2 and M2 is for X2 in the range between what? 1.2 until 2.4 meter. Why it is 1.2 to 2.4? Because again, go back up there. This is X2, isn't it? So X2 doesn't start from 0. It starts from 1.2 here, isn't it? But this region that you cut, it is between this and that. So from 1.2 to 2.4. 1.2 to 2.4. Okay, this region. So this region must be correct, right? So we can go on. We can Next, actually what we really have to do is we have to cut the one in the middle. So let me, okay, so I'm going to erase this first. Okay, the third card. So the third card will be here between this and that, right? Because this, the first card is between here. This second card will be between here. Okay. The third card will be between this, right? So the third card. So okay, let me write one. This is the first, second, and then this is the third. Okay, so card, we take the left again. It doesn't matter, but yeah, it depends on you. So this is at A, 18 kilonewton. Then you have 9 kilonewton. You have 9, another 9 kilonewton. Okay, you cut. So the next 9 here is actually somewhere here. So you cut between, before the next 9. Okay. So what else do you have? You have this 1.2 meter. You have this 1.2 meter. And then you have this other less between 0 to 1.2 meter. Okay. So at the section you have the V3, M3. Again, we do this positive sign convention. Okay. And then you define X3. Again, it's up to you whether you want to define X3 as this or you want to define the whole way. Okay. So this is X3. Right. So same procedure. We do the summation of forces in y equals to 0. So here the V3 will be 0. Alright, try to do that. How about moment? So for moment, we do moment again. We do the moment about the section. Okay, because we want to eliminate V3 in the equation. You can do here by doing, but again, don't complicate yourself. Okay. So about moment, assuming positive, let's say O, counterclockwise. So you have M3, right? Positive M3, and then you have minus 9 X3 minus 2.4, which is this load, the moment generated by this load. Y X3 minus 2.4, X3 minus 2.4. So only this arm, right? Because we do moment about this point, about the section. Next, minus 9 X3 minus 1.2, isn't it? Minus 9, this one, minus 9. Okay, this is the direction of the load. And then the arm is this, which is X3 minus 1.2, right? And then we have plus 18 X3 equals to 0. Why positive 18 X3? Because no. Wrong. This is positive, this is positive, this is negative. So right, because all these they follow the same direction, the same counterclockwise direction. Only this 18 causes the counterclockwise direction, right? So 18 X3 minus equals to 0. So if we rearrange this M3, so what will happen is that we have the 9x3, 18x3 minus 18x3 will be 0, and we have the 9 times okay, here minus 2.4 minus 1.2 will be minus 3.6 times 9 will be minus 32.4, okay, kilonewton. Okay, it's minus here, but when you bring to the other side of this equation, then it will be plus, right? So this one, okay, good. Now I don't have space. So this x3, the range will be between 2.4 to here, which is 3.6 meter, right? Why? 1.2, 1.2 here. So the x3 here, the section is between this and that, which is 2.4, because we measure x3 from the left, from the very end, 2.4 until 3.6. Right? So you have the three equations, 1, 2, and then the three equations. Okay? So you can go on. I mean, actually you have to go on. Cut here and then find the equation, cut here, find the equation. But actually here, if you understand it correctly on the symmetry part of this, can you see that this is symmetrical? You have 9, 9, 9, 9, symmetry about this, the middle in the middle, okay? With the same 18 kilonewton, so it's symmetrical. So actually this part and that part will be the same, okay? So I'm going to erase this and going to draw the shear force and bending moment diagram.